Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we are going to discuss about the methods of determining coefficient of viscosity. So what are the different methods are there for identifying coefficient of viscosity? We'll discuss in this lecture. So before going to that, let me tell you what is the meaning of this viscosity and why viscosity is required or why the necessity of measuring the viscosity. So already we have discussed this viscosity part in our starting lecture, and also the types of viscosity and the units and what is the Newton's law of viscosity, all the things we have discussed. But just I'll give a hint about the definition about the viscosity. So viscosity is nothing but, we can say, this is the degree up to which a fluid can resist the flow under a applied stress or under a applied force, we can say. That means the liquid which is there is also having a resistance, okay, to resist something. So when you apply some kind of stress or force to that, so it is also having a limitation. So it will be resist up to that force or stress up to some limit. So based on that, we can identify the viscosity of the liquid. So that we'll see with different methods. So the methods, as I mentioned here, actually there are different type of methods are there to measure the coefficient of viscosity. So what other methods are there? Capillary tube method, or you can say CTM. So capillary tube method is there, which we are going to discuss today. Capillary tube method. So this is one of the method, and apart from that, also falling sphere resistance method is there. Then rotating cylinder method is there, and orifice type viscometer also one method is there. So there are several types of methods are there to determine the coefficient of viscosity. So out of this, today we are going to discuss about this capillary tube method is there. So here you can see I have taken a diagram for this, and in this there is a tank is there. This is the tank, and in the tank we have the fixed head. Okay, that means the height of the liquid which is present in the tank, that should be a fixed head is there, and which is connected to this tube, and there is a measurement tank is there, and the liquid which is there, it should be come out from this. So I'll tell you in the details. So let me write. So today we are going to discuss about the capillary tube method. So in this, actually this concept is based on the Hagen-Pauli method formula, or Hagen-Pauli concept, you can say, that law. Okay, also we have discussed this Hagen-Pauli law in our previous videos. So based on this concept, or based on this theory, we are going to calculate this coefficient of viscosity. Okay, Hagen-Pauli law. So this constant, or you can say the capillary tube method, is based on this Hagen-Pauli law, and which is this law is going to use for this to calculate the viscosity. So here you can see the diagram what I have taken here. So this is the diagram for the capillary tube method, and in which the liquid of, like the viscosity of liquid which is going to be measured, that is kept in the container or the tank, what I said, with a constant head, and also the liquid need to be maintained at the constant temperature also. So here the temperature should be constant of this liquid, and this liquid is need to be passed through this capillary tube which is present here. Okay, so the head of this, or the height of this capillary tube and this tank, will be in the same position. So that is the H. So when the liquid will be flows from this tank, okay, and it will be also raised in the capillary tube, and by this, with the help with this pipe, the liquid will be flows, and that liquid need to be collected in a measuring tank. Okay, and the liquid is collected at the measuring tank, as I told, when it is across this pipe, and with a time period. Actually, we need to measure with a time period. We need to, like, so when the liquid is coming out from this, and this liquid is suppose falling. Now it is, initially it was blank. So suppose this is also, we have the measuring scale will be there. Measuring scale is there, like a 5 centimeter, 10 centimeter, 15 centimeter. There will be scaling will be there, and we need to take a stopwatch so that we can identify, like within 10 second or 20 second, what is the volume of liquid or the fluid which is present here, that is filled in this tank. So that need to be measured, and so that we can identify the rate of liquid which is collected in the tank as per the second, so that we can determine that one. And the pressure head H, the pressure head H will be measured at the point which is far away from the tank. So now what are the terms are there here? We need to write it. One is H. H is nothing but the pressure head difference, or you can say the difference of pressure head for a length of L. So this one we can write difference of pressure head. What is the difference of pressure head? Now you can see the container is there, that fixed head is there. So this is the head, H is there. So here we have the different pressure will be there, and at this point we have a different pressure level. So the pressure at this point, and which is with a distance of L. So H is nothing but the difference of pressure head for a length L. This is the L is there. That means here what is the pressure is there, and here what is the pressure is there. That means we need to check it. And next is D. So diameter of the capillary tube. D is the, you can say, diameter of the capillary tube, or you can say the pipe which is connected, this one. Okay. And next is L. This is diameter of tube. Just you can write the tube. And next is L. L is nothing but the length of the tube, which is the difference of pressure head is known. Like from this point to this point, what the pressure head difference is there. So the length, so you can say the length of the tube under which the difference of pressure head is known. So this one also, just we can mark it as a length of tube. The total, not the total length of tube, like from which point we just mark, that also we can write length of the tube for which under the difference of pressure head is known. And next, one more important term is there, density, rho. So density of the liquid, or the density of fluid which is present in the tank. Okay, so these are the terms are required to calculate the coefficient of viscosity. Now, as I told in the starting, that we need to follow, or we need to obey the laws of Hagen-Poiseuille concept. So what is the Hagen-Poiseuille law? That we need to check it. So already in the previous videos I have derived this Hagen-Poiseuille formula, or this the derivation we have already done. So based on that, I can write that Hagen-Poiseuille, by using this formula I can write H equal to the formula actually 32 mu u bar L divided by rho g d square. Actually this is the formula. And here also one more thing is there, the main thing, the coefficient of viscosity. Here also we need to consider the mu. Mu is nothing but the coefficient of viscosity we can consider. Okay, coefficient of viscosity which is supposed to be determined. Yeah, so this is the formula of Hagen-Poiseuille formula. Okay, H equal to 32 mu u bar L rho g d square. So here we know that mu is the viscosity, u is the velocity, and L is the length, rho is the density, g is the gravity, d is the diameter. So everything is known to us. But here if you see, okay, let that length is directly clearly given. So let u bar, so all the terms are very common to us. Rho is the density, d is the diameter which is fixed, mu also need to be calculated, length is already fixed here. So the velocity of this here, that can be written in different way, like what is the formula for that? U bar equal to, we know that q by a, because we know that as per the equation q equal to av. Okay, in the continued discharge equation we can write q equal to av. So u bar equal to, or v equal to q by a, that's why I've written. So this one we can write q by, what is the area? Pi by 4 d square. Okay, and now as I told, the q is the rate of liquid which is flowing through the tube. Q is nothing but the rate of liquid which is flowing through the tube. So we'll just put the value, this u bar value will put in this equation. On behalf of putting the u bar velocity, we'll put this equation in this case. So after putting the value here, what we can write? H equal to 32 mu q by pi by 4 d square into L divided by rho g d square. Okay, so this is the formula. Now what we can write, this one we can take it to down. Yeah, this 4 is there, pi by 4. So pi by 4, what will be there? It will be, goes up. Pi by d square will become down, and 4 into this 32, that will be 128. So this is 128 mu, and this is q L, and here in the bottom it will be there, rho g d square, again pi into d square will be there. Okay, and this is h. But ultimately what is our goal? Now we need to find out the mu value. We need to find out the mu terms. So let's keep the mu terms one side and remaining all terms to take it to other side. So by that, what is going to written? So we can write this denominator term. Let's take it to the other side. So we can get it here. Pi is there, rho, pi rho, again g, pi rho g, h is there, let's write h, again d square, that is nothing but d4. Okay, and denominator will be there, this one 128 mu already gone. So this one you can write q into L. This is the equation for finding the viscosity value, coefficient of viscosity value, and this diameter d value need to be taken very carefully. Okay, so this is the equation. So I hope you understand like how to determine the coefficient of viscosity. This is just a experimental work. Mostly in the lab itself we used to do this experiment to identify the value of viscosity. Anyway, so this is the theory part of this, determine the coefficient of viscosity by the capillary tube method. And here nothing is there, just you need to keep the we need to consider a tank, okay, a constant head tank where the liquid or fluid need to be kept here, and that need to be flows through this, and meanwhile we need to keep a capillary tube here, okay, so that the pressure, due to the pressure difference of this, the liquid will be raised with a particular height. Then this height should be equal to the height of this tank, and it will be not go beyond this one, obviously. So, and the liquid which will be flows here through this tube, okay, and that need to be collected in a measuring tank, and the measuring tank is given here to identify the rate of flow also. So at a particular what time we can identify what the volume of fluid is coming out, and this is the concept only. And meanwhile we need to follow this Hagen-Poiseuille law to identify the value of coefficient of viscosity. Okay, so we know that this is the equation for the Hagen-Poiseuille law. This one we can follow my previous video to identify this one, how you have calculated, how you have derived this one, and based on that we can easily identify what is the formula. Now see, this is the coefficient of viscosity formula. What the terms are there? Now rho is there, g is there, h is there, density and acceleration due to the gravity, h is the head height, and d diameter of that, and 128 q l. Q you can identify from here, the discharge from this, l is the length. So everything we can identify from here. So I hope you understand this video. If you're having any doubt and query regarding this, you can give a comment on the comment box. Thank you all.